If you're anything like me, you've probably dealt with your fair share of trip breakers or high electricity bills and outages from your utility company. In this multi-part series on designing the ultimate smart home, I'll show you how I would fix all of these issues with an entirely new smart home built from scratch. My name is Steve, and this is it-alchemy. If you didn't catch the last video where we talked about the structure of the home, check it out here. In this video, we're diving into all things electrical. Just about everything in a modern smart home runs on electricity. It's crucial to make sure that your home's electrical system has the capacity to run everything smoothly. This is especially important if you're using high voltage devices like air fryers or microwaves or space heaters or even power tools out in the garage. To handle all of that demand, you're going to need a solid load center. Older homes often have panels rated for 100, 125, or 150 amps. Most new homes these days have a 200 amp panel. I wouldn't recommend going below that, even if your electrical service is less. There are several options from companies like Leviton and Schneider, but personally, I prefer the Span Smart Panel. The Span Smart Panel is a load center with 32 remotely controllable circuits. It can monitor each circuit individually and give you detailed analytics, even offering insights into your energy usage. If you plan on using solar or battery backup system, the SPAN panel can help manage your power when the home switches between grid, solar, or battery. So what makes it really shine? The ability to create virtual critical load panels. If there's a power outage, you can designate which circuits will run on the backup power. This feature extends battery life by up to about 40%. The downside, it's pretty expensive. So I'd only recommend it if you're also planning on having solar or battery backup, which of course we are. Speaking of solar, we're going to need some solar panels. I like the VSUN 490N panels. They're efficient at about 22.65% with 490 watts per panel. Yeah, they're a bit larger than most, but we've got plenty of space for our ground insulation and we won't mess up our roof. Up here in Alaska, summer power generation is no issue since it's light almost all day long. But during the dark days of the winter months, particularly in December and January, the sun barely makes an appearance. So for that reason, I probably dropped this to a VSUN 440. It's a bifacial panel. It's a bit lower output at 440 watts, but it captures the reflective light from the snow, giving us a little bit better power in the wintertime. Solar is a great step toward energy independence, but with modern smart homes that have a ton of devices running 24/7, they can be a little power hungry. It's hard to generate enough power consistently to run the entire home, especially during a power outage. That's where batteries come in. Battery storage complements your solar by allowing your home to keep running, even if the grid goes down. The SPAN panel integrates with these batteries to help you designate which circuits can get powered during a power outage. For the actual backup batteries themselves, I'd probably go with Enphase's 10 kilowatt hour 4th generation battery. It has 7.08 kilowatts of continuous output, it's reliable, it works well with the system. It's not the cheapest option, but it's part of a really dependable ecosystem, and trust me when I say this is not a system you want to have issues with. Along with the panels, we'll also need microinverters. For those, I'd prefer the Enphase IQ8. These microinverters convert DC power from the solar panels into usable AC power for the home. The benefit of these microinverters is they also optimize performance, meaning that if one panel underperforms or fails, it doesn't bring the entire system down. One of the most common tasks in a smart home is controlling devices plugged into outlets. Smart plugs are an easy solution, but they can be bulky and block other devices from being plugged in, so why not make the outlet itself smart? The Eve Energy Outlet combines control, scheduling, and energy monitoring all in the standard outlet. Essentially, this makes every device plugged into it smart, even if it wasn't designed to be. Plus, it supports Matter and Thread for easy communication. Now let's talk switches and lighting. For switches, I typically stick with regular dumb switches, and here's why. Lighting is permanent. It's installed in the ceiling, and either the switch can be smart or the light itself needs to be smart. But my preference? The light. For interior lighting, I recommend recessed lighting in the common areas like the living room. Accent lighting can be good to highlight features like artwork, while LED strips are great for stairs and hallways. In kitchens, task lighting over cooking areas is key. In bathrooms, task lighting around the fixtures and LED lighting around the mirrors works great. For bedrooms, I like to use a mix of task, accent, and primary lighting, along with LED lighting around the beds or desks. For TV displays, ambient lighting improves the viewing experience. And if you use smart lights like Gobi, every light is controllable in terms of color, brightness, and effect. Since most of their devices support Matter, they're easy to set up and can work in conjunction to create all kinds of scenes within the home. The dream is starting to really come together. Solid, well-built, energy-independent home with all the right electrical components. We covered a lot of ground today, but if I left anything out or if you have any ideas, let me know in the comments. Don't forget to like this video and subscribe to my channel. Follow along for the next video as we dive into HVAC systems. Thanks for watching.